Alright, some new material for us. This is called the product rule that we're going to work on today. We want to find derivatives of products. Pretty straightforward. What we can do when we have polynomials is we may not be able to tell exactly what this derivative is right here as it is. You might think it's 2x times 2, or I'm sorry, it'd be 2 times 2x, the derivative of each, but that is not exactly how it works, and here's a way that you can prove that. We know how to simplify this thing. We can FOIL, and we would get that this function is, it would be 2x cubed, you would have a plus 5x squared, a minus 6x, and a minus 15. The derivative of that then, f prime, would be 6x squared plus 10x minus 6, which is definitely not the same as this 4x that we thought it might be. So we need to come up with some sort of different rule for some of these problems, because this first one we just did, yes, I could FOIL out this function f and find my derivative f prime of x. That's fine. I can't do it with a problem like this. 2x plus 5 times sine doesn't work so well. There's no way that you can distribute this out in a way that we have all polynomials. In fact, you would get 2x sine of x plus 5 sine of x. I could find a derivative of this part. This would be 5 cosine of x when I take a derivative, but I don't know what to do when I have 2x times sine of x. So we need to find some sort of new way to take a derivative, and actually there is one. It's called the product rule, and here is the product rule. If we bring it up on your screen, this is really big. We cannot forget it. When you have two things multiplied together, so I'm calling them f and g that I'm multiplying, the derivative is f times g prime plus g times f prime. And that is very confusing, very weird to say. So I say it this way: 1 d2 plus 2 d1. So it's the first function as it is times the derivative of the second function, plus the second function times the derivative of the first function. So you have lots of ways that you can try to remember it. I think this is the easiest. 1 d2 plus 2 d1. So let's use that here in some example problems we have using this product rule, 1 d2 plus 2 d1. So this first one, yes, we could FOIL. We just did it in the first example. But just so you can see how it works, let's try to find the derivative using this product rule. So the product rule is the first times the derivative of the second. The derivative of this second guy here is 2x. Plus the second times the derivative of the first. Well, right now it doesn't look anything like what we had of the 6x squared plus whatever, but I can simplify this. It would become, when you distribute out, you get 4x squared plus 10x, and we also have a 2x squared minus 6. So when you combine those together, I have a 6x squared plus 10x minus 6, which is exactly what we said the answer should have been. So you can use the product rule, or I think it's actually easier just to FOIL out for problems like number 1. Number 2 here, though, is a problem where obviously we can't do that. So we need to find a different way using this product rule. Well, the product rule, again, is the first times the derivative of the second. The derivative of sine is cosine. Sine goes to cosine, plus the second times the derivative of the first, which is just 2. There you go. That's your answer. There's not much more I can do to that. They would probably bring this 2 out in front of sine of x, so it would probably look more like this with a 2 in front. Sine of x times 2 would be 2 sine of x. That's the way you would match it on a multiple choice answer, just like that. Let's look at a couple more examples following the same pattern. These ones are more straightforward for ones that you would see for a product rule type of problem. Number 3 here, if I do y prime, this is a product because it's x squared times e to the x. I have the first times the derivative of the second. The derivative of e to the x is e to the x. Well, that was easy. Plus the second times the derivative of the first, which is 2x. And there you go. That's your answer. Now, they probably would write this a bit differently, x squared e to the x as it is, but it's commonplace to put the polynomial in front of e to the x. So probably it would be written like that, or I guess they technically could factor out an e to the x and leave you with x squared plus 2x. I guess you could technically factor out an x there and be x times e to the x and have x plus 1. All of those are valid answers. I would stop right here, but if you have to match a multiple choice answer, make sure you keep an eye on what could possibly be done and doing some simplifying. Let's go here with number 4. If we go y prime for this one, again, it's a product. You got two things being multiplied. So the first times the derivative of the second, derivative of ln, is 1 over x, plus the second, which is ln of x, times the derivative of the first, which would be 15x squared. And again, a lot of ways you could rewrite this. If it doesn't tell you to rewrite it, or you're not matching multiple choice answer, you stop right there. But I can definitely simplify 5x cubed times 1 over x is just 5x squared. And then this second part, I'll just put it in proper order with the polynomial in front of the natural log. And again, I could probably factor out, if I needed to match a random multiple choice answer, I could probably pull out a 5x squared to leave 1 plus 3 ln of x. That last step, not as important. I would definitely say right here would be where you would see a multiple choice answer potentially coming up. All right, and finally here in 5 and 6, we're going to look at a couple of problems that kind of mix in some multiple rules going on here. So with this first one, f prime of x equals, this first part, x to the 4th times cosine of x. Let's do that first. That is a product. So the first times the derivative of the second. Notice I put that parenthesis right there. If I hadn't done that, you know what that would look like? It would look like 4x, or x to the 4th minus sine of x. Well, we don't want that. It's first times derivative of the second. So be careful on that. Plus the second times the derivative of the first. Okay, well that took care of just this part of my equation. I still have more. I still have e to the x as my next problem here. So I need to also take the derivative here of e to the x. Well, lucky for us, the derivative of e to the x is e to the x. So there you have it. That's a fine answer. The way it would be written, this negative would probably go in front. So it would be negative x to the 4th sine of x plus 4x cubed cosine of x, and then plus your e to the x. That's probably how it would actually be written out, again, on a multiple choice answer. All right, one last one for us to look at here. Let's find a nice color. G prime we'll find on this one. G prime of x here is going to equal, well, first, 5 times sine of x. It kind of looks like it could be a product rule, but it's not. 5 is just a number in front. We can just go right away and say this is 5 cosine of x. If we want to do product rule and say here's your first, here's your second, we could go that the first times the derivative of the second plus the second is sine of x. The derivative of the first would be 0. That part would just go away anyway. So 5 cosine of x is your derivative, which we could have done just with constant multiple. Now this part, though, we're definitely going to have a product rule. Square root of x and e to the x. Remember, square root of x we don't like. Let's call that x to the 1/2 power instead. So first times the derivative of the second plus the second times the derivative of the first. 1/2 x to the negative 1/2. And again, I would leave it like that just so we can see how that would simplify out. This first part, 5 cosine of x, would stay the same. This would be back in probably your root x e to the x format. This part would have the 1/2 in front. E to the x would be up top, so probably e to the x like that. And it's x to the negative 1/2 power, so that's a square root of x, but on the bottom. So there's your product rule. Plenty of examples for you to look at. And we'll be doing plenty of it.